Hey friends, welcome back to Civil Engineering Master. As we know, slab, beam, column and footings are the structural members. Slab is one of the structural member which covers the larger area of the structure. Also, it is the roof of the structure. As we all know that in a conventional method of construction, the slab load will transfer to beam and the beam will transfer the load to column and the column will transfer all the superstructure load to the substructure, that is foundation. So this is the actual procedure in conventional method. This we call it as a slab beam construction. So what is the alternate to this conventional method of construction? Instead of using slab and beam, what is the alternate method? In this video we are going to discuss an alternate method of construction instead of slab beam construction method, which is a flat slab. In conventional construction method, the slab will be supported by beams to transfer the load to the columns. Whereas in flat slab method, the slab will be directly resting on column and the slab will directly transfer the load to column without beams. So in this video, let's discuss what is flat slab, why do we need to provide flat slab, what are all the IS code recommendations for flat slab, and what are all the pros and cons about flat slab. All these details let's discuss in this video. So without delay, let's begin now. First, let's start with conventional beam slab construction. So as you can see in this image, this is the conventional beam slab construction. Here you can see the slab. This is slab and this is beam and this is column. So in this method of construction, the slab will transfer the load to beams. So beam is the supporting element for slab, and then the beam will transfer slab load as well as the beam weight to the column, and the column will transfer load to the foundation. So in this way, this method will vary from flat slab. Let's look into what is flat slab. The slabs which are directly supported by the column, that is called flat slab. It is a two-way reinforced structural system, include drop panels or column capital. This type of flat slab construction is aesthetically appealing. There will not be any beam in the flat slab. As you can see in this image, the slab is directly supported by the column and this is the drop panel. Next, let's discuss why do we need to provide flat slabs. We know about the conventional method of construction which will be having slab and beam. In some places where headroom is restricted, headroom means the distance between the floor to the bottom of the beam. We provide flat slab where headroom is restricted. So in some places where we have the public hall, offices, warehouses and big auditoriums and all, we should have the flat surface, we should have the more headroom. So in that cases, we cannot provide beams because the space will be larger and we need to provide the depth of the beam more. That will affect the headroom height. So in that cases and all, we have to go for this kind of flat slab which will be having the flat soffit and flexibility in design layout. So this is the one major advantage of flat slab, where we have the bigger buildings like public halls, warehouses, offices, commercial buildings and all. We wanted to have more headroom. In that case, we need to provide this flat slab. In conventional method of construction, the beams reduce the available net clear ceiling height, that we can also call it as headroom. The beam reduces the ceiling height, net clear ceiling height. So if we provide flat slab, we will be getting the more clear ceiling height. Before getting into the types of flat slab, let's have a quick recap of what is flat slab and why do we need to provide the flat slab. Flat slab or the slabs which are directly supported by columns. It is a two-way reinforced structural system which will be having the drop panels or column capitals. It is mainly used to increase the net clear ceiling height, and also it provides the flat soffit, and then it provides flexibility in design layout. For example, if we wanted to make a false ceiling, and in that case and all, it will be very easy if we go with a flat slab system. It is mainly used for warehouses, public buildings, auditoriums, party halls. In these kind of structures, the flat slab can be mainly used. Now let's look into the types of flat slab. We are having four types of flat slabs. One is slab without drop and without column head. Second one is slab without drop and column with column head. Third one is slab with drop and column without column head. Fourth one is slab with drop and column with column head. This is the first condition, slab without drop and column head. So here the slab is directly supported on column. There will not be any drop panel or column head. And this is the second condition. This is the second one. Slab without drop and column with column head. So there is no drop panel over here. The column is provided with column head. And this is the third one. Slab with drop. The drop panels will be like this, and column without column head. There is no column head. And this one is the fourth condition. So the drop panel is also there and also column head is there. Slab with drop and column with column head. Next, let's look into the proportioning of flat slab. First one is thickness of flat slab, second one is drop, and third one is column head. Proportioning of flat slab has been given in IS 456-2000 class number 31.2.1. That is thickness of flat slab. The thickness of flat slab shall be generally controlled by consideration of span to effective depth ratio given in 23.2. In class 23.2 we will be having the slab span to effective depth ratio. For cantilever we will be having for simply supported, and for continuous we will be having the span to effective depth ratio. The same shall be applied here. For slabs with drop conforming to 31.2.2, span to effective depth ratio given in 23.2 shall be applied directly. Otherwise, the span to effective depth ratio obtained in accordance with provisions in 23.2 shall be multiplied by 0.9. So for this purpose, the longer span shall be considered. The minimum thickness of slab shall be 125 mm. So this we have to make a note. The minimum thickness of flat slab shall be 125 mm. So here it is little bit confusing because first we should know what is the condition for drops in 31.2. Then we'll discuss this. In class number 31.2.2, the conditions for drops are given. The drops when provided shall be rectangular in plan and have a length in each direction not less than 1/3 of the panel length in that direction. So the length in each direction shall not less than 1/3 of the panel length in that direction. For exterior panel, the width of drop at right angle to the non-continuous edge and measured from the center line of the column shall be equal to 1/2 the width of the drop for interior panels. So if we provide the drop, there will be interior panel and exterior panel. So for that the condition is given here. For exterior panel, the width of drop at right angle to the non-continuous edge and measured from the center line of the column shall be equal to 1/2 the width of drop for interior panels. As we have discussed in 31.2.2, for slabs with drops conforming to 31.2.2, if that satisfies the condition of 31.2.2, then span to depth ratio given in 23.2, here also it is given, shall be applied directly. If that is not satisfied, then span to effective depth ratio obtained in accordance with provisions in 23.2 shall be multiplied by 0.9. So for this purpose, the longer span shall be considered. So if that satisfies the condition, we can directly consider the span to effective depth ratio. If it is not satisfying this condition in 31.2.2, then we need to multiply the span to effective depth ratio, which is given in 23.2, shall be multiplied by 0.9. So for this purpose, longer span shall be considered. The third one is column head. Where column heads are provided, that portion of a column head which lies within the largest right circular arc pyramid that has a vertex angle of 90 degree and can be included entirely within the outlines of the column and the column head shall be considered for design purpose. Let's look into the figure. Critical section for shear in flat slab. See, this is the slab without drop and column without column head, slab with drop and with column head. You can see here the vertex cone as it is given here. Vertex angle of 90 degree can be included entirely within the outline of the column and the column head. Similarly, here slab without drop and with column head. So here there is no drop panel and slab is provided with only column head. Here also the vertex angle shall be 90 degree. Here the flat slab can be related to footing. As you all know, footing we design and then we check for punching shear. Similarly, here also in flat slab we check for punching shear because the heavy load is transferring to the single column, right? The column, it looks like a pole. The heavy load which is transferring to the pole, so the shear will be more. And then we need to check the punching shear. See here, everywhere it is mentioned that d by 2 punching shear has to be checked at a distance of d by 2. See that this is the critical section for shear adjacent to drop. Here also it is given critical section for shear. Similarly, in column head also critical section for shear. So these drop panels, column heads are provided to resist the shear force. Let's look into the advantages of flat slab. Flat slab need less formwork as it has the flat soffit and it requires less formwork when compared to conventional system of construction. Straightforward reinforcement detailing, so it is more effortless to place. Since it has no beams, the straight reinforcement can be placed effortlessly. Flexibility in room layout, better appearance and offer better diffusion light. It provides better fire resistance than a conventional floor system. Flat slab has few disadvantages as well. The thickness of the slab is more when compared to conventional slab system. Difficult to control slab middle strip deflections. Limitation in increasing the slab span. Suitable for lightweight partitions. So friends, I hope you all like this video. Please do comment in the comment box if you have any queries. Your comments are always welcome. If you like the content, hit the like button and also share it with your friends. If you want more details about flat slab or any topic related to flat slab, please do comment in the comment box and don't forget to subscribe the channel for more videos. Thank you for watching.